guys, hello and welcome to the channel Eduzone Learning Solution. सो गाइज आज आपको मैं पढ़ाने वाला हूँ चैप्टर नंबर 4 केमिस्ट्री का, जो कि है केमिकल थर्मोडाइनमिक्स। ठीक है, सो एकदम बेसिक से समझेंगे इसको, एकदम स्क्रैच से समझेंगे इसको। ठीक है, सो ये पार्ट 1 सीरीज़ होने वाला है। चैप्टर आपका बहुत बड़ा है, बहुत इंटरेस्टिंग भी है। सो थर्मोडाइनमिक्स वर्ड देखो, ये तो आपने सुना होगा। अभी ये कहाँ पे सुना होगा? ये आपने फिजिक्स में भी सुना होगा। एम आई करेक्ट? राइट। सो थर्मोडाइनमिक्स का जो रिलेटिविटी है यहाँ पे, जो हम अगर कंपेयर करेंगे तो आपको थोड़ा सा जो है यहाँ पे सिमिलैरिटी देखने को मिलेगा। सब कुछ बताऊंगा आपको धीरे से। उससे पहले जो है आपको एक रिक्वेस्ट करता हूँ कि पहले क्या कर लो, पहले आप सब्सक्राइब कर लो चैनल को, और अंत तक देखने के बाद अगर आपको वीडियो पसंद आता है तो ज़रूर से लाइक कर देना। ठीक है, चलो तो आगे बढ़ते हैं अभी। सो देखो भाई, यहाँ पे है हमारे पास ये डायग्राम है। इसी को देख के हमें समझना है फर्स्ट ऑफ ऑल थर्मोडाइनमिक्स। केमिकल इसको अलग कर देते हैं फिलहाल। ये जो केमिकल है आपका, केमिकल थर्मोडाइनमिक्स, इसको थोड़ा सा अलग कर देते हैं। ठीक है, केमिकल से आपको समझ में आता है कि जो भी चीज़ होगा वो रिलेटेड किससे होगा? केमिकल के रिलेटेड होगा, बराबर। डायनामिक्स, थर्मोडाइनमिक्स, अभी ये क्या होता है? सो थर्मोडाइनमिक्स, सो देखो अभी आप इसमें 3 चीज़ देख पा रहे हो। जैसे कि हो गया आपका सराउंडिंग्स है, जैसे कि हुआ आपका सिस्टम है, और बाउंड्री है। ठीक है, सो यहाँ पे जो भी इम्पैक्ट होने वाला है आपका सराउंडिंग का, जो आपके सिस्टम पर इम्पैक्ट पड़ेगा, वही सारी एक्टिविटी को हम समझने वाले हैं आपके थर्मोडाइनमिक्स में। ठीक है, सो 3 चीज़ है। एक तो आपका सिस्टम है, सिस्टम के साथ जो है आपका बाउंड्री है, जो कि हम बोल सकते हैं एक इंटरमीडिएट है सराउंडिंग और सिस्टम के बीच में, राइट। और तीसरा जो है आपका सराउंडिंग है। सो यू नो ट्रांसफॉर्मेशन ऑफ लिक्विड वाटर इनटू वेपर, सॉलिड इनटू लिक्विड वाटर, और burning of carbon forming carbon dioxide, okay, so are accompanied by a charge in energy. Okay, so in dry cell the chemical energy is converted into electrical energy. So dry cell आपका क्या होता है बच्चा लोग? जो chemical energy होता है वो convert होता है किस में? electrical energy में, right? So on the other hand, in electroplating of metals, electrical energy is converted into chemical energy. यानी ये प्रोसेस जो नेचर की तरफ से होता है, मतलब ये जो है, अगर हमारे पास रॉ मटेरियल्स है इसके जो भी है, मतलब तो पॉसिबल है कि आपका जो है यहाँ पर केमिकल एनर्जी जो है कन्वर्ट किया जाता है इलेक्ट्रिकल एनर्जी में। और सेम चीज़ हम क्या कर सकते हैं? इलेक्ट्रो प्लेटिंग के थ्रू आपका जो इलेक्ट्रिकल एनर्जी है उसको कन्वर्ट कर सकते हैं केमिकल एनर्जी में। सो दस इट मे बी रियलाइज दैट द एनर्जी कैन बी ट्रांसफॉर्म फ्रॉम वन फॉर्म इनटू अनदर। ठीक है, सो देखो कभी कभी क्या होता है, एनर्जी ट्रांसफॉर्मेशन में कंजर्वेशन नहीं भी होता, वो फैक्टर भी आता है, तो वो भी मैं आपको बताऊंगा आगे चलकर। ठीक है, सो यस, हमेशा याद रखना एनर्जी जो है वो ट्रांसफॉर्मेबल होता है, चाहे आप इलेक्ट्रिकल से केमिकल में करो। ये पॉसिबल किसकी वजह से होता है? ये पॉसिबल होता है आपके ड्राई सेल की वजह से। ओके, सो ड्राई सेल की वजह से पॉसिबल होता है। चलो, so thermodynamics is concerned with the energy changes in physical and chemical ट्रांसफॉर्मेशंस। फर्स्ट ऑफ ऑल ट्रांसफॉर्मेशन ये कीवर्ड है, इसी को आपको जो है नोट करना है। ठीक है, सो यहाँ पे थर्मोडाइनमिक्स जो है ये किससे कंसर्न्ड है? इट इज़ कंसर्न्ड विद द एनर्जी चेंजेस इन फिजिकल एज वेल एज केमिकल ट्रांसफॉर्मेशन। ओके, so thermodynamics however give no information on the rates of physical or chemical processes or underlying mechanism involved in this. so जो chemical dynamics है ये आपको कोई भी related information, it will not provide you any information on the rate of what? On the rate of physical or chemical processes which are underlying mechanism which are involved in this. Okay. So now you know that at the bottom of dam, right, water is stored in a reservoir. It has certain potential energy due to its height from ground level, and its kinetic energy is negligible as it is not in motion. So काइनेटिक एनर्जी जो होता है, टोटल एनर्जी, वह क्या होता है हमारा? काइनेटिक प्लस पोटेंशियल होता है, जो आपका टोटल एनर्जी होता है। सो यहाँ पे जो है आपका काइनेटिक एनर्जी क्या होता है? ये नेग्लिजिबल होता है, क्योंकि ये जो है आपका लेयर इन मोशन नहीं होता। इसलिए एज द वाटर स्टार्ट्स टू फॉल डाउन through an outlet, its potential energy decreases and kinetic energy increases due to the डाउनवर्ड वेलोसिटी. डाउनवर्ड वेलोसिटी ये क्या हो गया, ये आपका एक टाइप का एक्शन हुआ, ठीक है. सो जब तक कोई एक्शन नहीं होगा उसका कोई रिएक्शन नहीं होगा. कहने का मतलब ये हुआ, अगर आपको किसी को एक्टिवेट करना है, अभी आपको क्या एक्टिवेट करना है यहाँ पे, आपको अगर एक्टिवेट करना है आपके काइनेटिक एनर्जी को, राइट. सो मोशन कैसा होना चाहिए, मोशन आपका होना चाहिए डाउनवर्ड. एम आई करेक्ट? नाउ यू गेटिंग द पॉइंट? If you have any doubt, then let me know in the comment box, which is open 24/7. Alright guys, chalo. It means that potential energy of falling water is converted into kinetic energy. Again, over here you can see that your energy, your potential energy is what it is transforming, actually it is converting potential energy to kinetic energy. However, it is possible vice versa also, but what would be the changes? The changes will only be in the direction we can apply the negative sign over here. That's it, right? So it depends on all other different situations. Okay, so now moving forward, we are going to observe the system and surrounding. As I told you in the second slide only, second or first slide maybe, that it consists of your boundary, system and surrounding. So boundary is the intermediate, right? Boundary is your intermediate. Boundary is your what? It is your intermediate, right? I had told that in that slide. So the key term is your system and surrounding. By this, what we are going to understand, that will I'll let you know in short, right? So you can see a part of universe under thermodynamic investigation is called system, right? All is your system. All is your system. All other parts of the universe outside the system, such as cylinder, room and others, are surrounding. There are only two things, bacha. Only two things means what? It will be either your system or either your surrounding. Now in system, suppose now I am taking, like over here it is mentioned that, see, all other parts of the universe outside the system, such as cylinder, room and others, like you can take the temperature also, it is also considered as your surrounding. It also comes in your, okay. So these are the thing, and your gas which is the inside the system, so it will be considered as a part of system. Rest all thing will become under your surroundings. Okay, are you clear with this? Okay, so if you have any small or any silly doubts, anything related to that, then let me know in the comment box. Okay, and if you want to get me personally attached, so how you can do that? You can do that by connecting me on Keval Cheda, right? This is my Instagram ID. Whatever doubts, whenever I will get the time, I'll surely reply to your message. Okay, so now kinds of system, as we learnt about system and its surrounding. So the system word will not give you a deep impression or a elaboration of what are the types of system. So basically the system are open system, closed system and isolated system. Now you can recognize that what are open. In seeing this, when you are observing this diagram, you will be able to relate what is open system, what is closed system and what is isolated system. So if you want to read this, you can read this. I will explain you directly without reading this. Okay, so you want to take screenshot, you can take the screenshot of these two slides. Okay, so see guys, so open system, as you can see this, your cup and saucer, right? This is your cup and this is your saucer. So inside the cup you can see it is written that energy. Now what does this mean? It means that your system, this is your system, contains some of the matter inside that. And what is your matter? It is your liquid, and it can be either a hot milk or it can be either a tea, right? you can imagine that by your own, right? So it can be milk or it can be tea or any hot liquid substances. Okay, so this is the energy which has some of the system consisting with some of the matter, right? So now why it is open system? Because as I told you intermediate, अभी ये intermediate क्या है बच्चा? Intermediate ये एक ऐसी चीज़ है which will let you know whether your system is closed, whether your system is isolated, or whether your system is open, right? So over here you can see that this is the structure of curve, but then let me know that it is closed from all side. Like it assume that it has four side, right? Left, right, up and down. Okay, now you're getting this. Now as observing, you can see that that left part is closed in a, it is kind of a container, the right part is closed and your bottom part is also closed. But what about the upper part? Is it closed or not? No, it is open, so it is not completely closed. So we will term this as what? We will term this as an open system. So over here you can see the transformation of energy. Like it would have some of the ashes which is coming out from your system. Are you getting that? देखो ये गर्म दूध है तो इसका धुआं बाहर जा रहा है. सो यू कैन सी दिस एनर्जी इज नॉट कंजर्व्ड हियर, राइट? एनर्जी कंजर्व्ड क्यों नहीं है? क्योंकि इसका जो हीट है वो रिलीज हो रहा है सिस्टम में. जो अगर मान लीजिए स्टार्टिंग में 80 डिग्री सेल्सियस है, सो क्या ये ओवरऑल 80 डिग्री सेल्सियस होगा? नहीं होगा, नहीं होगा, डेफिनेटली नहीं होगा. क्यों नहीं होगा? क्योंकि उसका ऐश जो है वो निकल चुका है. सेम एज क्लोज सिस्टम. क्या इसमें निकलेगा? यस निकलेगा. माना कि ये क्लोज्ड है लेकिन ये आइसोलेटेड नहीं है, यहाँ पे एनर्जी ट्रांसफर होगा धीरे धीरे. वॉट विल हैपन? इट विल टेक प्लेस ड्यू टू वॉट? इट विल टेक प्लेस ड्यू टू योर रूम टेम्परेचर. सो जैसे कि मैंने आपको बताया था, सराउंडिंग में आपका रूम टेम्परेचर भी आता है, मैंने आपको बताया था, राइट? सो सराउंडिंग में आपका टेम्परेचर भी आता है, राइट? सो मान लीजिए अगर आपका अंदर का एनर्जी जो है इनसाइड द कप इज 80 डिग्री सेल्सियस, बट इफ it is room temperature is 37 degrees Celsius, then let me know, will it be continuously will remain constant at 80 degrees Celsius? No, it will not. After being the closed system also, it will not remain constant at 80 degrees Celsius. Why? Because the energy is getting transfer, right? Energy is getting transfer from one place to another place. This would become average. Okay, so it will not constantly come up to the 37 degrees Celsius. It will gradually decrease, right? So it depends on your time factor, right? So time factor over here is the important thing, okay, which will let you know that after this time that 80 degrees Celsius would be fall up to your 37 degrees Celsius. It cannot go lower than this. It would be higher than this, or it would be up to this, like 37 degree. It will not fall down, right? Are you getting? Now what is isolated? Your thermos, your best example, where you store hot tea. Even that the thermos act with the surrounding, right? But it is very rare case. It depends upon the quality, right? It depends upon the quality, which quality do you use, because it has many of the hybrid components also. So it depends on company to company which create thermos, right? So isolated system will remain longer, will remain long lasting, right? So it could be more than 12 hours, right? It could be more than 12 hours. Depends on the quality, right? It depends on the quality. So it would be more than some would have more than 8 hours, but definitely it would not have less than 6 hours. Okay, so this is the minimum number where your isolated system will not transfer the heat from system to surrounding. So that is actually the relation. So I hope आपको बच्चा क्लियर हुआ होगा. डाउट आपको कुछ भी होगा तो बिंदास पूछ लेना, आप रीड कर सकते हो. देखो जो भी मैं आपको पढ़ा रहा हूँ, आपको डिटेल में और भी जाना है, डीप जाना है, तो आपको तो आपका टेक्स्ट बुक रीड करना ही है. यहाँ पे मैं आपको कॉन्सेप्चुअली बताने की कोशिश कर रहा हूँ, राइट? कॉन्सेप्चुअली आप पढ़ोगे, समझोगे, सुनोगे, देखो, आप वीडियोस के थ्रू जो भी देखते हो, पढ़ते हो, तो आपके लिए जो है लर्निंग ईजी हो जाता है। आप सुना हुआ चीज़ जल्दी से उसको जो है याद कर सकते हो। वो जल्दी आपके माइंड में जो है इट क्रिएट सम स्पेस, राइट? इट क्रिएट सम स्पेशल स्पेस इन योर माइंड, बिकॉज इवन you are visually seeing the content, but you are also listening the content, which create a better impact. Okay, so now what is extensive property? So we'll come up to over here. Extensive property, we have two different types, that is intensive and extensive. Now extensive property means the property which depends on the amount of matter present in a system. It only depends on the amount of matter, like it can be a mass, volume, internal energy, heat capacity, number of moles, etc. I can directly say it depends on the quantity which is present inside your system. Now, what is intensive property? So, a property which is independent of the amount of matter. Yes, this is the sentence. Which is independent of the amount of matter in a system, it is called intensive property. Now, what are the example? Pressure, temperature, like these are the independent factors. Surface tension, yes. Viscosity, yes. Melting point, boiling point, even this does not depend on your extensive property, which will not depend on your quantity, which will be independent of your extensive property, specific heat. So you have to remember this all things, right, guys? So now moving further, we can see the change of state. Yes, this is the important term. What is the change of state? Like you can see over here in the diagram, that changes in variable and change of the state, right? So we can assume two different states, like initial state, which is also known as fresh state, and the final state, which is last state, right? So the property which depends on the state of a system and independent of a path followed to attain it, it is called a state function. Now what is a state function? So state function is the keyword which define the property which depends on the property which depends on the state of a system, right? It depends on the state of the system. Like I can say simply as a state in the form of ice, in the form of solid, in the form of water which is liquid, in the form of gas, right? So these are the different form of state. So it which depends on the state of a system and independent of path followed. Now it is not dependent on path, it can be any random path which you don't know, right? So it can be independent of path followed to attain it, like to grab that, to achieve it. That is called as state function. Now we will come over here in thermodynamics equilibrium. So as we had learned that PV is equals to nRT, the concept come over here too. Like you can see the terms over here, gas has temperature, pressure and volume. What does this mean? It has its specific pressure along with temperature and volume, right? These are the state function continues to be constant as long as piston is motionless and no heat exchange take place. This is an equilibrium state where heat doesn't take place, exchange of heat doesn't take place. This system can be known as the equilibrium state. The present of state would be your equilibrium state, right? So now move the piston in upward direction so that the gas expands. It passes through states for which pressure, volume and temperature are not specified and vary continuously during the movement of the piston. The gas would be in non-equilibrium state. I would also say over here the equilibrium can also be defined as the static state, right? Right? So now you think why I am saying this as the word static state. Okay, so the word itself equilibrium define that it is in static, it is not in dynamic. Like the terms, what are the terms? Pressure, your temperature, your volume, these are the terms which are going to create some impact to your system, right? So your system, if it is in rest state, I can say whether see, it is in rest state or non-moving state, then it would be considered as a static state or equilibrium state. If your system is performing any of the action and due to impact of these three terms, your pressure term and your temperature term and your volume term, this would create impact on your system, but your system is not now in equilibrium state. So the result would be different if it is considered or if it is compared with your equilibrium state, right guys? So stop the movement of the piston. Suppose at this stage the pressure and volume of the gas are respectively and the temperature is called P2, V2 and T1. The state function are constant since the piston is motionless. Yes, it would be constant if your system is motionless. Your piston is considered as your system now, okay? So the gas is then in another equilibrium state. System is said to be in thermodynamic equilibrium when its state functions do not vary with time. Yes, when its state function do not vary with time, it is called as your thermodynamic equilibrium. Thermodynamics considered here is limited to equilibrium states. Now coming with the type process and its types. A transition, what do you mean by transition? Transition from one equilibrium state to another is called a process. There are different types. Again, transition like changes in your system. After all, it is going to come back to that system, but the between process which has happened is your transition. Now to understand this, we are divided in different types like isothermal process, isobaric process and isochoric process. Isothermal process, it is the process in which temperature of the system remains constant throughout the transformation. It is the process in which what? Temperature of the system remain constant throughout the transformation. Now what is isobaric? Isobaric process, the pressure remain constant during the transformation, not throughout, the only during the transformation. In the laboratory, chemical reaction are carried out in open container at constant atmospheric pressure, that is your del P. Okay, now what is isochoric? It is a process during which volume of the system remain constant during the transformation. Now volume, like it can be defined as your you are storing matter in any of the container, in any of the container. Your container over here is considered as what? It is considered as volume. Now it is constant, it remains constant throughout during your transformation. So this process will be known as what? Isochoric process. Are you getting, guys? Okay. Now what is adiabatic process? Over here this diagram can help you to understand this. So you can see the motion of the graph, how it is reacting from the point VA to point VB. So like adiabatic process, a process in which there is no exchange of heat between system, and surrounding. In adiabatic process, the system is completely insulated from the surrounding. For an exothermic process, the heat is released which rise temperature of the system. Now this is for the exothermic process, right? If the process is endothermic, the temperature falls like this. Your volume from VA to VB, your temperature will going to fall. This results in either increase or decrease in your internal energy of the system. Now coming to our last point, that is reversible process and irreversible process. Now in thermodynamics there are some we can say recreation of like some process which can be taken place, but that can also be reversible, like we can perform that vice versa. So how to get that? So the process is carried out infinitesimally slowly, it is carried out rapidly, so you have to compare the points. Now in irreversible it will be carried out rapidly, but in reversible it will be carried out out very slowly. At any state the equilibrium is not disturbed, but over here equilibrium may exist only after the completion of the process. Till the time it would not exist. It takes infinite time for completion. It takes finite time for completion, because in finite time irreversible means only one time. Reversible means you have to trace that back. So work obtained in the process is maximum, yes, because it is reversible. Over here work obtained is process not maximum. It would be minimum or limited number of time. So thank you guys for cooperating today. So thank you so much. If you like this video, then please do like. It's a request that you please do subscribe as well. Okay, so whenever you are watching the video, always check the description. Always. Sometime if I forget something in the video, so where I am going to mention that, I am going to mention that in description, right? So mostly if I won't update also, but whenever I'll get the time, I'll also update the description too. So okay, thanks Dan. Goodbye for today. That's it. So we'll meet you in the next video. So तब तक के लिए take care. Thank you and bye bye.